how we choose to embrace and shape the development of this technology to ensure that we get the AI that we want. I think Kieran's point was very well made at the start. There's a lot of, there's a bipolar view of AI out there at the moment, but we have the opportunity to shape that future and how it's created. So this slide here is illustrating the power of generative AI. Generative AI is about technologies that can create and process content, be it text, image, video, speech. What the slide is showing you is the development of how we can use AI to create a poem, create a video, create an image by just simply using the same prompt, a robot picking a flower. Okay. So content is at the core of this revolution, and ADAPT has been working on digital content and AI technologies for digital content for over 15 years. As a Science Foundation Ireland funded research centre, we bring together academics from across Ireland, and we want to work with you to shape the future that this technology creates for us. So, generative AI, the impact it's going to have is clear at this point. Its largest impact is going to be on the knowledge worker in terms of improving their productivity, the quality of their work. We're seeing that it also helps with upskilling and bridging skills gaps. A recent McKinsey report highlighted some of the areas that it's expected to have major impacts. This is around customer support, product R&D, software development. One area we'll have to completely rethink is how we teach programming and computer science, an area that's close to my heart. And we're also seeing from an innovation side, McKinsey reporting that companies are already seeing the benefits of adopting AI in terms of the bottom line and in terms of decreasing costs. However, a recent Irish government report highlighted this, very recent, I think it was last week. It talked about generative AI as possibly being a general purpose technology, similar to steam, electricity, and the internet. That's the potential transformative economic impact of this research. But there are challenges around it. For example, in terms of the dynamics in the marketplace, the technical and financial costs of entry into the market, and also societal fears about how it will affect people, economic displacement and workplace displacement. The strange thing about this revolution is that at its core, it's based on this idea of language modeling. Language modeling is something that's been around for a long time. I've been working on it for over 20 years. I think my first paper on language modeling was in 2003. And the basic concept of language modeling is just predicting the next word in a sentence. So when you think about it, it seems odd that that is the kind of core technological trigger that's enabling all of this change. But actually, what's coming with that is when you take that simple task and you combine it with huge scale, we get emergent properties in the technology. And in fact, apart from the usability and the ease of use which comes through this task because it's fundamentally about language, which is our core communication platform, apart from that ease of use, the emergent property that scale gives us with this task is the ability for the AI to do meta-learning, to learn how to adapt to new tasks. And actually, it's strange, like this wasn't my doing, but actually the title of our research center, ADAPT, is actually perfectly placed for this revolution because it's about the ability to adapt and learn new tasks that is driving a lot of the innovation that we're seeing today. In other words, if you train a large language model to predict the next word, if that model is big enough, it can then easily be adapted to new tasks because of emergent properties. And I'm going to go through in the next few slides some of the techniques that have been developed to adapt models. And also, it's interesting, these techniques, They've been developed to adapt models, but the fact that they've worked has also shown us the power of scale. The first one I'm going to talk about is instruction fine-tuning. So remember, we have a pre-trained language model as our starting place. This is simply a large model, and I'll talk about size later on, a large model trained to predict the next word. How can we get it to do useful things? Well, one thing we can do with instruction tuning is we can continue to train the model. Okay, so this is instruction tuning. We're continuing to train the model. But here what we choose to do is that all of the text that we continue to train it on to predict the next word is curated so that the examples are instructions and response pairs, so questions and answers. And it turns out that if you train a language model, continue training it on a large corpus, well, and it's not as large as for pre-training, but on a corpus of examples of different instructions, questions and answers, then the model learns how to interpret and follow instructions on new tasks that it hasn't seen before. Okay, so what we're saying here in this process, we start with a pre-trained language model, predict the next word, trained on general text. We then continue training the language model, much less scale and compute required here, but here we're focusing on teaching it how to follow instructions. And then we can get it to work on new tasks by giving it new instruction sets that it hasn't seen previously, and it's able to adapt across. So, to give you an example, in natural language processing, we might take a pre-trained language model, we train it on common sense reasoning, we train it on translation. You'll see that in each of these examples, there's a description of the task with the answers given to it. That's what we're training it on, and it's learning to predict the next word in those tasks. But then having trained it on multiple sets of these instruction sets, it's then able to do a task that it hasn't seen before, and to do that at a level of accuracy that surpasses the previous state of the art. So it's that ability to take a pre-trained language model and adapt it to a new task that is driving this revolution. Interestingly though, and this is, I remember when I first came across this is when I started getting worried. We don't have to, this adaptation doesn't have to require the continued training of the model. We can also adapt the model by just changing the information we give in the question we're asking it, okay? So I've talked to you about instruction tuning, where we continue to train the model, but here we have this example called few-shot prompting, or in-context learning. And that is where we give the description of the task to the model as part of the question we ask it. So for example, if you have a pre-trained language model, and this only works if the model is of a sufficient scale, by the way. This is one of these emergent properties. Smaller scale models aren't able to do this. If you make them big enough, then what they can do is you can give them the orange text is previous examples that illustrate the task you want it to do. Here we're asking it to, the examples are showing it how to analyze a piece of text or a review for sentiment. Is it positive or negative? We show it some examples as part of our input to the model, and then it's able to carry out the task for us. So by just showing it what we want it to do, it can adapt to that task and give us the output we desire. In context or few-shot prompting. Okay. What this graph is showing you, okay, is that the ability of a model to use the information you include in the prompt within its context that you input to it is dependent on the scale of the model in terms of size. Okay? So here you have three different models. We're measuring the scale of the models in terms of their number of parameters. The largest one is 175 billion parameters. Parameters is simply a word for the variables in the model that are fitted by looking at the data. Okay? Training goes into that. What you're seeing is, for the three different model sizes that were tested, the distinction between the natural language prompt and the no prompt isn't that important. They're described here, but don't worry about that. Just look at the natural language prompt examples. You'll see clear differences in the ability of the models on a task in terms of the number of examples you include in the prompt as it's given. Okay? So the more examples you include in the prompt, the bigger the gap between the performance of the models in correlated with the size of the models. So again, size gives adaptation. Okay. To take this a step further, chain of thought reasoning. Okay? Another property that comes with size is the ability for a model to include reasoning and planning as part of its processing of a query. So here we have a standard prompt, a few-shot example. Well, actually, it's a one-shot example. In the prompt input, we've given one example of the question and answer type we want. We give another question in. It actually got the question wrong. Okay? Big enough, but in a big enough model, if in the examples that you give it, you include some steps, the intermediate reasoning steps, then the model is able to get the same question right. Okay? Same model, it's just big enough that it can do a chain of reasoning, and then it can use the intermediate reasoning steps to improve its own performance. One way of understanding what's happening here is when we prompt the model to output its intermediate reasoning, we're in a way telling the model, use more compute, use more memory when you're doing this answer. Okay? Have a scratch pad, be able to write on paper, and it's able to use that extra output, you can see the output is longer, to get the correct answer. Again, though, it's adaptation. It's adapting to the task. The fact that these systems can use in-context learning, can use the information that we add into the prompt, or prepend to the question that we ask it, also enables a set of other approaches for improving model performance. Retrieval augmented generation is something that you'll see in a number of our examples later on. And this approach really targets a number of the problems that LLMs have. Sometimes in their outputs, it's very hard to know what sources they used that drove them to give you the response they did. The information they get, because a pre-trained language model is so large, they're not frequently updated. So the information that's encoded in the model can go out of date, and also this can lead to hallucinations. Okay? If you ask the model a question about something it doesn't know about, it will still generate an answer for you, very fluent answer, but it's going to be an hallucination or confabulation. The idea with retrieval augmented generation is to say, if a model is big enough that it can do few-shot prompting, in other words, a model is big enough so that it can use extra information, background context that we give with the query, then what we can do is when we get a query in, we can go and retrieve relevant information from another knowledge base, a vector database store that we can keep up to date easily, prepend that to the query, and then the model will use that extra information in generating its output. Okay? So this retrieval augmented generation has been shown to improve accuracy. It enables us to do fact checking because we know what sources the model is grounding its outputs on. And it's also easy to update the information the knowledge uses because we simply update the knowledge base that we retrieve from. So I've gone through a number of different methods there, all building on these emergent properties. And they give us opportunities to develop different strategies for how we want to use these methods to adapt our model. One way of thinking about it is in terms of whether we want to adapt the model in terms of the knowledge it uses, to keep the knowledge up to date and to be able to do source fact-checking. Another way of thinking about how we might want to adapt the model is in terms of the model behavior. How does it respond to an instruction? What type of language style does it use? We can do prompt engineering to modify both. But if you have high demand for up-to-date external knowledge, I suggest you'd include RAG, Retrieval Augmented Generation. If you have a high demand in terms of the instruction or the language style or the specific terminology you wanted to use, fine-tuning is probably useful, particularly if you're going to use the model very frequently. And a nice benefit of this is that these are, while they're complementary in terms of how they update the model, they're also complementary in terms you can use both approaches and blends of these approaches. And there's a range of research going on in all of these areas. Through these emergent properties, we can see a range of different abilities coming through in these models. We've got the basic abilities. We've done an awful lot of work in ADAPT in terms of multilingual research, knowledge representation, low resource languages, domain adaptation. There's the emerging abilities of in-context learning, reasoning, and instruction following. And we also have another stage or layer that's coming forward is using the reasoning abilities of these models as an orchestration layer in an agent-based system. Okay, and there'll be examples. There's some posters later on about where we've used AI, or agentic AI, to drive system behavior. That is, the language model is planning and orchestrating the use of other tools within the system so that an AI system can take on higher level tasks, decompose them, and take care of extra steps for us. For example, an AI system can book a holiday for you. Okay. Unfortunately, the graphic's gone off a little bit. I wanted to talk to you a little bit about size. Okay, how big does a model need to be to get these emergent abilities? Okay, that arrow should be at a 45-degree angle there, folks. We should be seeing three-dimensional coordinates. Okay, that's unfortunate. So this is AI in action. I should have used Gen AI instead of PowerPoint. So you can think of three axes that we can think about size: compute, data, and model size. Model size, the number of parameters we use. Okay, GPT-4 is estimated to have 1.76 trillion parameters. Llama, the amount of data. Okay, Llama was trained 15 trillion tokens. For tokens, just think words. That's the scale of the data it's been trained on. Gemini Ultra, which I understand is the most compute-intensive model so far. I just talked to Dragos about this. I have that number down as 5 to the 25 flops. So that's floating point operations, the number of computations used to train the model. I think that's an underestimate. We think it's 10 to the 25. And that's important, by the way, folks, because we're actually, at the moment, I think in Europe, we'll be using the amount of compute used to train a model in order to categorize a model in terms of whether it's a frontier foundation model that would be regulated at a European level versus is it a model that might be regulated at a national level. So the compute budget used to train these models is, you can see that we're already building bridges into policies and regulation. Okay, these numbers are important and go the whole way up. That's one of the interesting things about generative AI. We're going from core computer science straight through societal issues up until policy and regulation, and we have to be able to build bridges across those. You can see some of the size, the estimated training costs that come with this type of engineering effort. And that's one of the things we need to think about in terms of market concentration and barriers to entry for this type of technology. Thinking about the things, the highlights and the fine-tuning I've talked about, there's an overview you can think of in terms of a standard life cycle for adapting a large language model. There's pre-training, which is the predict next word, general text, usually done on massive scale models, a large amount of compute and data required. Probably most organizations won't do this. You'll have a few large players which will be pre-training from scratch. But then you can go to fine-tuning, domain tuning, training the model to use specific terminology, instruction tuning, teaching the model how to follow instructions, and then using or leveraging the power of in-context few-shot learning, either in terms of retrieval augmented generation or prompt engineering. As you go across those stages, the amount of data and compute required reduces, and it opens up the possibility for more people to use those adaptation techniques. Okay. So, coming back to where we are today, what do we need to think about if we're developing an AI strategy? Okay. One of the things you might want to think about is, okay, do I use a large language model or generative AI as a service? Do I pay a subscription fee and use it over the cloud? Or do I, my organization, want to bring it in-house, develop our own model? You can there's open source models out there, pre-trained models that you can use as a base, and then you can adapt those models using instruction fine-tuning, RAG, et cetera, and prompt engineering. That's one significant question you need to think about in developing an AI strategy. And the answers to that is going to be dependent on multiple factors: the needs of your task, the specificity, how quickly does the data update, how often in your organization will you be using the model, What's the compute budget, the data budget, and the in-house technology expertise you have? And do you have the relevant data available to you? So there's a range of factors that will form that decision, but that's a key decision you need to think about. Looking across Gen AI at the moment, we did a SWOT analysis on this. And this comes back to that question of, there's a lot of opportunities out there, but there are some challenges and threats. And I think that across the panel that we're going to have later today and in the afternoon session where you'll see the demonstrations, we'll discuss both the strengths and threats that were coming through in Gen AI at the moment. Looking to the future, some of the things and areas I imagine that we're going to see a lot of work on, that distinction between big general models, okay, typically models that you access as a service, versus the development and deployment of smaller in-house models is one area that I think that division is going to become more stark. Agentic AI is going to become bigger, more prominent. There is an ongoing and a huge amount of work on how we improve the scalability and efficiency of these models, both in terms of data and compute. Clearly, we need more work done on bias mitigation to ensure that we get the ethical and fair systems we want. And we can see that multimodal capabilities is another area that a lot of work is going into. So these are just some of the areas I think we're going to see a lot of breakthroughs in the future. And finally, to finish, we've talked about the fact that AI is transforming how content is generated, how we interact with computers and how we interact with each other, and how it's having a massive impact on society in terms of the work, education, leisure and entertainment, okay? And in that type of a context, I think it's really important that we bring together people with expertise ranging across these topics. And that's what ADAPT does. So we're bringing together academics from across Ireland. Individually, they're all world leading within their disciplines. And we're fostering an interdisciplinary, multidisciplinary perspective on AI. We have experts at the core on generative AI at those foundational computer science methods. We have experts who are working, who's a focus on interaction. How do you implement these systems within human processes? And we have a huge amount of expertise in terms of governance, ethics, policy, standards, regulation. So I'm really excited to be part of ADAPT because all of these different expertise is coming together. And again, as a national government-funded centre, we want to work with you to help you develop the strategies you want and to work with you as partners in order to ensure that we shape the way AI is created and deployed so we get the AI that Ireland needs and wants. So thank you for your time.